In this video, we'll be defining a function. A function f consists of a set of inputs, a set of outputs, and a rule for assigning each input to exactly one output. We call this set of inputs the domain of the function, and we call the set of outputs the range of the function. Let's consider a simple function f. We can write y equals f of x equals x squared. Let's define this function on the set of all real numbers. That means this function takes in any real number and squares it. So f of 3 is equal to 3 squared, which is equal to 9. We can say that the range of this function is the set of non-negative real numbers. That's because we can never get a negative real number from this function, because the square of any real number is non-negative. We can often graph functions on a Cartesian plane. We usually denote the horizontal axis of a graph with the variable x, and we usually denote the vertical axis of a graph with the variable y. Moreover, we refer to x as the independent variable and y as the dependent variable, because y depends on the value of x. Let's consider another function, g of x. We can say the domain is the set of numbers 1, 2, and 3, and the range is the set of numbers 1 and 2. This function takes an element from the domain, which can be 1, 2, or 3, and maps it according to its parity, meaning if it's odd, it's mapped to 1, and if it's even, it's mapped to 2. Every function has a domain where it's defined. If a domain is not given, we simply take the domain to be the set of all real numbers x, for which f of x is a real number. However, we can have functions which are not defined on the entirety of the domain. Consider f of x equals the square root of x. This function is defined only when x is non-negative, because we cannot take the square root of a negative number. This is actually sometimes called the natural domain. We can write the domain in a variety of ways. The first way is writing in set builder notation. We write it as follows. We say that x is the variable that we're looking at such that it has some property. If we want the function to be defined between 1 and 3, we can write x such that 1 is less than x, which is less than 3. We can write an equivalent notation using interval notation. In interval notation, if we want a value to be included in the interval, we write it with a square brackets. But if we want it to be exclusive, we write it with a round brackets. Note that when we have infinity, we always write it with a round brackets. Finally, a function can have multiple parts, and we say that this function is a piecewise function. We can define different equations and intervals for each part of this function. And that concludes today's video. Thanks for watching.